I had a couple questions on the homework from last night.
Yeah.
When I was going through the answers in the back of the book,
Yeah.
I noticed that number 25 or 23 and 25 were not. I did not get what the book got.
Okay.
So I asked someone else in my family who was good at math, and they got the same answer as I did.
Okay. What was the first one again? 23?
23.
23. Okay. So integral from 0 to 3 of S of t and R of t. So the idea, right, is that you want to use the fact that you can break it up into two pieces.
Yeah, which because since at the top you'll have the integral answers from 0 to 3, 3 to 5,
Right.
yada yada, which it'll give you 10 plus 11 minus -1.
Right. So from 0 to 5 is 11. From 3 to 5 is -1. So, right. So we're using the fact that from 0 to 5, it would be 0 to 3 plus 3 to 5. And we want only the 0 to 3 part. So 0 to 5 minus 3 to 5. So 0 to 5 is 11. 3 to 5 is -1. So negative 1. So 22?
Yeah, according to the back of the book, it's 24.
Okay.
And number 25, according to the back of the book, it's -7. And I got 0.
Okay. I'll check with Hartman on that. But let me just, so that was 23. 5.2. So the 5.2 25. Yes, so that definitely is 0 because it's from 3 to 3.
Yeah, but according to the back of the book, it's -7.
Well, okay. The only thing I can think of, right, it doesn't matter what you put there, the answer is going to be 0.
Yeah.
It's possible that this is because of the new edition, like some problems got added and the answers didn't get shifted down too. So.
Yeah.
I'll blame Hartman. If anyone's had Hartman, you know he has problems. He can't quite get his act together. I always like to pick on my colleagues.
Yeah, that's pretty much all I had.
Oh, okay. So yeah, you can peel out whenever or hang around and listen. Doesn't matter. Virginia, you said you had some? Or?
Yes, sir. Could you go over number 17? I did not understand all of it.
Okay. Oops. Okay. 5.217 is, so you have the velocity is given by minus 32t plus 60. So that's velocity.
Yeah.
Right. So the object will be thrown straight up and straight back down. I mean, right. So technically, it can be joined on the axis, but so the object is thrown straight up and then it's thrown straight back down. But if you were to draw a velocity curve here, then you would get a line. I guess you get a line that looks like that. And when t is 2, you're there, and that's 64. So in that picture, the point is that
Okay, it says it's thrown from a height of 48 feet. And so I made the x-axis, like, I don't know, I made it 48.
right, okay, sorry. So it is thrown from a height. But as far as the graph of velocity is, it doesn't know the height. That would be in a height graph.
Okay.
Yeah, which we can do. We can do it here in a second. I think you can answer some of the questions without knowing 48, but let's see how far we can get. So part A is just on velocity. So max velocity, all you do is look at the picture and see if it's the highest point.
It's where it's the launch velocity.
That's right. So the max velocity should just be 64, right?
Okay, yeah.
Okay. So that one's there. 2, what is the object's maximum displacement? So maybe I'll have to think about building here. Is the object going up and it's going to come back down? And
Wouldn't it be easier to calculate the time first, then the maximum displacement, instead of the other way around?
well, so where does the maximum displacement, but what time does it occur?
2 seconds is when the velocity equals 0, which will be the maximum height from where it goes, and then you have to decide whether the maximum height or going from 48 down is higher.
Right.
And finding the maximum height will give you 112, and you subtract 48, which will give you 64. But you wouldn't have found that without finding the maximum or the time, which is part C.
Okay. Yeah, I mean, it's certainly possible. These things can be out of order. So, let's see. So, I mean, and even, that's probably part D even, right? When will the object, oh, no.
No, it's part D is when it hits the ground.
Right, right. So,
And even the hint doesn't really tell you anything. It pretty much only gives, like, the hint doesn't really give you anything. It already gives you what the C value when you find the antiderivative velocity, which will give you position.
right. So sometimes these parts you want to, do more math before you actually can answer some questions. And so it depends on the problem. In this case, it's clear that we can do it with only this graph. Max velocity, we just look for the highest point. But I think, yeah, for these others, we are going to want to know what the graph for position is. So we do have to go back and we do have to see calc.
Sure.
Yeah, because after you find the time, then you can plug that into your position graph and find the maximum height.
I think that's what I did. So like the first thing I did is like I actually did B. I found the integral, and then like I made it equal to 0 to find T, and then I plugged it back to find the velocity.
Okay, yeah, that's that. I agree. I agree with that. So if you did take the antiderivative of this function here, what do you get?
I got
Nate,
-16 squared plus 64T plus C.
Plus 64T, right? Plus some constant, right? Which you'd always get when you do antiderivative.
which will be 48.
Yeah.
Right. So, but then, yeah, so it would be initially some number you wouldn't know, but because you're told that when T is 0, S is equal to 48, then you could go back and solve for that by plugging in T equals 0 and S equals 48. And so you would get -16T squared plus 64T plus 48. Does that make sense, Virginia?
Yes.
So once we know that, then we want to find the displacement, which again, is not the total distance traveled, it's how far away you are from the start. So you can see that it would come from either from the starting point up or the starting point down. So from the starting point up, that it reaches the top, and this is definitely not scale, when T is 0, or T is 2, when T is 2. You can see that from the velocity top when T is 2. So
Hey, you got that from the velocity, hey, and finding when velocity equals 0, solve for T.
right. Yeah, exactly. Yeah. So you can either solve it analytically from this or from a picture by looking at it as well. So either way is fine. So S of 2, you plug in 2 here. And so yeah, it'll be -16 times 2 squared plus 64 times 2 plus 48. And that's -64, so that means there's one of those.
112.
12. So it goes up 112. but then it would go down, or sorry, not up 112. The position is 112.
Yeah, and since you start at 48 and you're talking about displacement, you have to subtract 48 from 112 to get the displacement, and if that is greater than 48 to the ground.
Right, so it goes up 112 minus 48 is 64,
Yes.
okay? And it goes down 48 from the starting point. So that one right there is the max displacement.
Okay.
Yeah. And the time at which max displacement, you're right, we have already done that. That's at 2.
So max displacement is when the object is at the highest point on the path in this case?
In this case, yeah. It's
Okay.
always just which point is the farthest away from where you started.
Okay.
Because the object is thrown straight up or straight down, the max displacement is going to be at the top of the trajectory,
Okay.
towards the bottom of the building. If you didn't throw it if you threw it really slow, then it would go up just a little bit, it would fall a long way, and so the max displacement would be
Yeah. This displacement is pretty much the distance away from the original point.
That's right. And so then the max displacement is 64 feet. The max displacement time is therefore T2, because that's when it does hit the highest point. And then the last one, when does it hit a height of 0? Well, that's for part D here. You can just set the position.
And the only way to do that is using the quadratic formula.
You might be able to factor that. I think you probably can factor
Tried that, but it doesn't work.
Okay. Doesn't work?
It doesn't work if you try to factor.
Okay. So what do you get for your, you should get 2 times, right? But one won't make sense.
Yeah, well, from doing the quadratic formula, you'll get root 7 technically, but you also have to account for the time from being thrown, which will give you the 2 plus or minus root 7, and whichever is greater, which will give you the time, so it'll be plus root 7.
2 plus root 7?
Yes.
I got that. That's what I used to get with velocity. I got 2 plus root 7 and 2 minus root 7. But I didn't take account that's what I was supposed to use to find D.
I mean, does that make sense now, or?
Yeah.
No, it's not making sense.
So the S function here that we actually have is the height above the ground. That will tell you, you plug in the time, you'll get the height. So if you plug in 0, you get 48. That makes sense because you're 48 feet off the ground. So it's not starting at the top of the building. It's literally tells you the distance from the ground. So if I want to know what time it will be when it hits the ground, just take this equation and set it to 0. Yeah, the hint on displacement, you can do some stuff where it's based solely on, I think it would be more awkward to try to center everything off of that and then think of this as the 0 and work down. I don't think that's probably the best way to go about it. So I would just come up with this curve. This tells you how far you are off the ground. And then just set that to 0 and use the quadratic.
Thank you, sir.
Okay.
Yep. Thank you.
All right. Yeah.
Sir, can you show me how to work 13D?
13B.
D, sir.
Yeah. So the symbol just means what is the area between the x-axis and the function between x is 0 and x equals 1. If it's below the axis, it's considered to be negative.
Okay.
So I guess in that picture, it's here, it drops down, it comes back up, and obviously things are kind of not quite drawn to scale. But you're at least told that this area is 4, that area is 4, that area is 4, and that area is 4, and this is pretty good. So if you wrote down 0 to 1 of your function like this, the answer is -4, because it's 4 units below the axis.
Because it's 4 limits below the x-axis.
Correct. Everything above the axis is treated as positive area. Everything below the axis is treated as negative area.
So I'm not doing like, I'm not taking like, I'm not just like replacing fx with 4 and solving for it, because like what I did is like I put integral 1/0 of 4 dx. I said 4 times 1 minus 4 times 0, and I got 4.
What you're doing is you're technically doing the integral 0 to 1 of the function that's given.
And so that was the function I was given at first.
That's right.
And then I plug in 4 into it.
Well, we're jumping a little bit ahead to, I think it's section 5.4 that says, in order to evaluate this, you need to first find the antiderivative of this function first. Then you can start plugging in some numbers. But for right now, we're just trying to say that this symbol means draw the graph y equals 3x squared minus 3 and find the area that corresponds to between x equals 0 and x equals 1. And that would be this area down here. Which if you weren't told before, we wouldn't know how to do it without any more advanced calculus techniques. So in this case, it just tells you that it's 4. You then just have to interpret it as -4 because it's below the axis.
Okay, I got it, sir. What about 16C?
Okay. So you are told that the, oops, I lost my, So you're told that the graph that you're shown is the velocity. So V starts off, goes down, comes back up, does this sort of thing. So the relationship in the picture is that if you wanted to know anything about your position or the distance that's traveled, the distance is equal to the area under the V curve. So for C, if you wanted to know the total displacement up to 5, you'd have to find the area. And let's see, this is 3, this is 2, that ends up with that. This is 1, this is 2, 3. We need to find all the area, and really the easiest thing is just to chop it into a rectangle and a triangle, and another triangle and another rectangle, and just find those 4 areas.
Okay, so break it down into rectangles and triangles, get the area of all those shapes,
Yeah,
and then add them together.
that's correct.
Okay.
And again, the catch is this area here, sort of put it in quotes, because if the area is above the x-axis, you treat it as positive, and if it's below, you treat it as negative.
Well, right now, like in this graph, they're all positive because they're all above.
That's correct. Yeah.
Okay.
Yeah.
Okay.
Now, if you had a case where the velocity looked like this, if that was the v, then this part up here means that you're traveling to the right in the positive direction. This area down here, because it's negative velocity, means that you're traveling back. So really what you're doing in this picture is you're starting here, you're traveling to the right, but at this point right here, you stop, and then you start traversing it backwards. And if the area on the top, the plus, is balanced by the area below, which is minus, all that means is that you return right back to where you were. And technically, the displacement would be 0. Because the displacement
Because it will be positive minus
the
the
home.
bottom. Because it will be the top minus the bottom.
Correct.
Okay.
Yeah.
Okay.
But yeah, and the one that you had, it's all positive. So you just add it up. And if these were any sort of weird curves, in section 5.2, you couldn't do it because you don't know how to find areas for weird curves quite yet.
Got it, sir. I think that was it. Maybe like, what about number 5?
Okay.
Number 5A.
Okay. So 5. Four, 2, 4. Okay. Okay. So even part A says you don't need to know any calculus. All this means is it's the area between y equals negative 2x plus 4 and the x-axis for x going from 0 to 1. So you have your line, you have your x-axis. If you just went from 0 to 1, then you only talk about the area in that range. So if you wanted to know what that is, then you could just break it this way into a triangle and a rectangle.
Another time it will be 2.
Right.
Okay.
So it looks like that this is still like 1 wide, too high. This is too high. So the rectangle is 1 by 2, so that one would be 2. The triangle is 1 by 2, but you always do 1/2 base times height. So that would be 1/2 of 1 times 2, so it would be 1. So this whole answer you just write equals 3 because it's an area. You don't have to do any fancy stuff. You just write down 3. Now, if you knew that, I mean, if you wanted to, be even a little fancier, that's the shape you're talking about, and that's called a trapezoid. And there are fancy formulas for a trapezoid where this is 4, and this is 2, and this is 1. What you do is you take the average of those two numbers, 2 and 4. So the average is 3, and then you just multiply it by the width.
Thank you.
As well.
Got it. Got it, sir. Yeah. I think that was it for me, sir. Thank you.
Okay. So yeah, just see you tomorrow. Hopefully you can get the homework done. You need a little more time for today. Just take a little more time. Try to aim for that 1 o'clock, but if you can't, then this first one I'll give you a pass just because you got to know it.
Yes, sir. Thank you, sir.
All right. See you.
See you.